This is Brenda Bartolome, and I'm discussing to you my course project for data communication and networking 3. The topic I've chose is the topics Introduction to Scaling Networks, the LAN redundancy, and the link aggregation. At first, we are discussing about the introduction to scaling networks. The objective of this is to describe the use of hierarchical network for small businesses. Describe recommendation for designing a network that is scalable. Describe the type of switches available to small to medium-sized business networks. Describe the type of router available for small to medium-sized business networks and the configuration of and verify the basic setting on the Cisco iOS devices. The network scaling needs is the hierarchical network design. As they grow and expand, all enterprise networks must support critical applications, support converged network traffic, support diverse business needs, and to provide centralized administrative control to enterprise business devices to provide a high reliability network. Enterprise class equipment is installed in the enterprise network. And hierarchical network design, this model divides the network functionality into 3 distinct layers. The first one is the core layer, this distribution layer, and then the access layer. The Cisco Enterprise Architecture, the primary Cisco Enterprise Architecture modules include Enterprise Campus, Enterprise Edge, Service Provider Edge, and the Remote. So this is the division for this, the 4 modules for the architecture. But the failure domains are area of a network that are impacted when a critical device or a network services experience problems. Redundant links and enterprise class equipment minimize disruptions of network. The smaller failure domains reduce the impact of failures on company productivity. The smaller failures domains are also simplifies troubleshooting, which black deployment. Each switch black acts independent of the others. The failure of the single device does not impact the whole network. Designing for scalability. It is use expandable, modular equipment or cluster devices. Include design modules that can be added, upgraded, and modified without affecting the design of the other functional areas of the network. It is create the hierarchical addressing scheme, use routers or multi-layer switches to limit broadcast and filter traffic. The planning for redundancy. This is the installing duplicate equipment, providing redundancy path. So this is the sample for the planning for redundancy. This is the wiring closet, the backbone with redundant links, which is our switches, and then the service form. Expanding the access layer. Expand the access layer connectivity can be extended through wireless connection. So this is the sample of that. And then the fine-tuning routing protocols. The OSPF works well for large hierarchical networks. And then the switches, this is the switch platforms. To select form factors include the fixed, the modular, stackable, and non-stackable. This is the campus LAN. This is the data center, the cloud managed, the service provider, and then the virtual networking. The port density. The port density of a switches refers to the number of the port available in a single switch. The port density of the 3 different switches, the branch, the network edge, and then the service provider. And then the forwarding rates. The forwarding rates define the processing capabilities of the switch by rating how much data the switch can process per second. A switch product line are classified by forwarding rates. So this is the 24 port gigabyte Ethernet switches, the capable of switching 24 GBs of traffic, and then the other one is the 48 port gigabyte Ethernet switches. The power over Ethernet. The power over Ethernet, or PoE, allows the switch to deliver power to device over the existing Ethernet cabling. These features can be used by IP phones and some wireless access points. The multi-layer switching deployed in the core and distribution layers of an organization switch network can build a routing table, support a few routing protocols, and forward IP packet. So this is the example of this. The router equipment requirements. The rules of routers is to interconnect multiple sites to provide redundant paths, connect ISPs, translate between medias types and protocol. So this is the provide broadcast containment. This is the sample of that. And the connect remote location. The group users logically the application of department and provide enhanced security. The next is Cisco routers. There are three categories of routers. The first one is the branch, the second is network edge, and the third is service provider router. At first, the branch is highly available 24/7. So the network, this is the branch, the sample of that. And then the network edge is this, high performance, high security, and reliable services. And it connects campus, data center, and branch network. And then this is the sample of the service provider router. The router hardware, it is fixed configuration, and then the modular. Fixed configuration built-in interfaces. The modular, it is the slot allows different interfaces to be added. Next is managing iOS files and licensing. Routers and switches are comes with Cisco iOS software. The network administrators are responsible for managing these devices. This includes initial configuration, verification, and troubleshooting tasks, as well as maintaining up-to-date images and backing up the configuration file. So this is our format for that. And then the in-band, this is outband and management. The in-band, it requires at least one interfaces to be connected and operational and use of telnet, SSH, or HTTP to access devices. The outbound, this is the outbound, is to require direct connection to console or auxiliary ports and in terminal emulation clients to access devices. The basic router CLI command. The basic router configuration includes the host name. This is the host name. Of course, when we type the host name so that we will know if it is switches, what kind of switch, router, and also the password is console, telnet, SSH, and privilege mode. Interface IP addresses, of course we need it, and enabling routing protocol. So in this area, this is the router and how to configure all the terminal. You can put the host name, enable secret class, line, and then the password. You can put the password here and then exact timeout, the line, V2Y, and the password, login, and exit. So this is the example for that. And then next is the basic routers show commands. The show IP protocol, this is the basic show commands we usually use every time we do config. The show IP protocol displays information about the routing protocol configured. Show IP route displays routing table information. Show IP OSPF neighbors displays information about OSPF neighbors. The show interfaces displays detailed information about interface. Show IP interface brief display all interfaces with IP addressing information and interfaces and line protocol status. It shows CDP neighbors, displays information and directly connected on Cisco devices. So the summary for the first topic is that introduces the hierarchical network design models that divide network functionality into the access layer, the distribution layer, and the core layer. It describes the how Cisco enterprise architecture further divides network into functional components called modules, define how routers and multi-layer switches are used to limit failures, explain that the good network design includes capable IP scheme, fast converging and scalable routing protocols, appropriate layer to protocols and devices that are modular or easily upgraded, identifies that the mission critical server should have a connection to two different access switches. It should also have redundant modules and backup power. And then it is recognized that the router and switches should be selected from appropriate categories to meet the network requirements. So that's the first introduction, that's the first topic. And now we are going to the second topic, which is the LAN redundancy. The objective of this is to describe the issue with implementing redundant network, describe IEEE 802.1 DSTP operation, describe the different spanning tree varieties, describe BBSD plus operation in switch LAN environment, describe rapid BBSD plus operation in switch LAN environment. It configured PBSD plus in a switch LAN environment, configured rapid PBSD in a switch LAN environment, and etc. And now we are going to redundancy at iOS layer and 1 and 2. The multiple cabled paths between switches. It is provide physical redundant in a switch network, improve the reliability and availability of the network, enables users to access the network resources despite path disruption. The issue with the layer 1 redundancy, it is the MAC database instability. The Ethernet frame do not have the time to live or it could be TTL attribute. The frame continue to propagate between switches endlessly or until the link is disrupted and breaks the loop. It results in MAC database instability can occur due to broadcast frame forwarding. And then the next is there is no more one path for the frame to be forwarded out. An endless loop can result. When a loop occurs, it is possible for the MAC address table, a switch to constantly change for the updates from broadcast framing, resulting MAC database instability. The broadcast storm. A broadcast storm, it occurs when there are so many broadcast frames caught in layer 2 loop that all availability bandwidth is consumed. It is also known as denial of service. A broadcast storm is inevitable in a loop network. As more devices send broadcasts over the network, more traffic is caught within the loop, thus consuming more resources. And this is eventually created a broadcast storm that caused the network to fail. The broadcast, and this is the sample for the broadcast storm. So this is our the message from here, and it goes everywhere. The PC forwards out a new broadcast that also get caught in a layer 2 loop. Duplicate unicast frames. A unicast frame sent into loop network can result in a duplicate frame of arriving at destination device. Most upper layer protocols are not designed to recognize or cope with a duplicate transmission. Layer 2 LAN protocols such as Ethernet lack a mechanism to recognize and eliminate endless looping frame. Duplicate unicast frame. So this is the sample for it. Both switch 1 and switch 3 have entry in their MAC address table for PC4. So this is the PC4, and both forward the frame accordingly. The spanning tree algorithm introduction is the STP ensure that there is only one logical path between all destination and the network by intentionally blocking redundant paths that could cause a loop. The port is considered black when used data is prevented from entering or leaving that port. Does not include Bridge Protocol Data Unit or BPDU frames that are used by STP or spanning three protocols to prevent loops. The physical path still exists to provide redundancy, but these paths are disabled to prevent the loop from occurring. If the path is ever needed to compensate for a network cable or switch failure, STP recalculating the path and unblock the necessary port to allow redundant path to become inactive. And now this is the STP algorithm. The redundancy increases the availability of the network topology to protecting the network from a single point of failure, such as failed network cable switches. When physical redundant is introduced into design, loops and duplicate frame occurs. Loops and duplicate frame have severe consequences for a switch network. Spanning tree protocol or STP was developed to address this issue. So now we can see the example of it. You see the switch 2 is forward the broadcast out of the port, except for the originating port in the black port. The STP port rows. The root port is selected in all root bridge switches and the per switch basis. Root ports and the switch port closest to the root bridge based on the overall cost of the root bridge. You see this one, this is the alternative root, and this is for the trunk 1, the trunk 2, and trunk 3. And then this is the root port, and this is the designated port. This is the designated port, and then the root port. A root bridge, I'm discussing now a root bridge. A root bridge is elected for each spanning tree instance. It is possible to have multiple distinct root bridges with different sets of VLANs. So this is the example for it. And now the path goes. This is the bridge ID. We can put the bridge ID here. The priority and MAC address, the same as S2 and S1. And then the 802.1, the BPDU frame format. So this is the format for the BPDU, the spanning tree protocols, and you can see here the BPDU propagation and process. S2 forwarded BPDU frames identifying itself as the root bridge for all switch ports. And then the extended system ID. The extended system ID value is a decimal value added to the bridge priority value in the bit to identify the priority and VLAN of the BPDU frame. So this is the 2 bytes. You can see here the bridge ID without the extended system, the bridge priority MAC address, and then this one is the bridge ID with extended system ID. This one have without extended system ID. This one have a extended system ID. Next is the S2 become the root bridge because it has the lowest MAC address. So this is the example for that. And the S1 become our root bridge. And then the list of spanning tree protocols or STP. And this is the list for it. STP or IEEE 802.1D 1998 and PVST plus IEEE 802.1 D, 1D, does 2004, the Rapid Spanning Protocol, RSTP, and then this is the rapid test, the multiple spanning tree protocols, or IEE 802.1s. Now the characteristic of the spanning tree protocols is to implemented on Cisco switches on a per VLAN basis in the form of BBSD+. This is the default configuration on Cisco switches. RSTP can be implemented on Cisco switches and per VLAN basis in the form of Rapid BBSD+. With BBSD+ and Rapid BBSD+, root bridges can be configured proactively to enable spanning tree load balancing. Overview of PBSD+. The network running PBSD+ have this characteristic. The network can be run independently. IEEE 802.1d STP instance for each VLAN on the network. The optimum load balancing can be resolved. One spanning tree instance for each VLAN maintained can be considerable waste of CPU cycles for all the switches in the network, in addition to the bandwidth issue for each instance for the BPDU. And this is the example for it, the PBSD+. So this is the root of VLAN 20, VLAN 10, and then the trunk. See, the same trunk. And then the forwarding port to VLAN, the blocking port to VLAN 10 is blocking the forward to the VLAN, etc. Now the port states and PBSD+ operation. So this is the port states, the processes, the blocking, listening, learning, forwarding, and disabled. Extended system ID and PBSD+ operation. In environment, the extended switch ID ensures each switch has a unique BID for each VLAN. So this is the example for the VLAN. VLAN default BID would be 32770. This includes enhanced support for VLAN requirements. And then next, still overview the Rapid BBSD+. So this is the preferred protocol preventing layer loop switches, independent instance or STP runs for each VLAN. RSTP supports a new port type and alternative port and discarding. There are blocking ports. RSTP defines port states and discarding, learning or forwarding, and then retaining backward compatibility, and then it keeps the same BPDU format except for the version field is set to 2 indicated RSTP, and the plug fields uses all 8 bits. And then the overview of Rapid BBSD. We discussed already this. And then this is the RSTP BPDU, the RSTP version 2 BPDU, and then this is the flag field. And then this is also the edge port of the Rapid BBSD+. You see the root bridge. And then this is our data. And this is our computer. Next is the link type. The link type can be determined whether the port can immediately transition to forwarding state. Edge port connection and point-to-point connection are candidates for rapid transition to forwarding states. So this is you see the sample for this. The root port, designated port, alternative port, edge port, and also the root port again. Catalyst 2960 default configuration. So this is the features: enable state, spanning, switches priority, spanning tree port priority, spanning tree port cost, VLAN port priority, VLAN port cost, and the spanning tree timers. And then this is our default settings: enable on VLAN 1, PBSD, etc. And then the spanning tree, you can see this. Oh, sorry. You can see the spanning tree timers. Hello timer 2 seconds, forwarding delay 15 seconds, maximum aging time 20 seconds, and transmit hold counts 6 BPDUs. Configured and verifying the bridge ID. So this is the sample for it. The PBSD configuring and verifying the bridge ID presented 200808. And then the configure and verifying bridge again, visual spanning tree and how it looks like. Next is a port fast and BPDU guard. So this is when a switch port, so this is the switch port, is connected with a port fast, that port transitions become from blocking the forwarding state immediately. The BPDU guard puts the port and an error disabled state on the receipt and BPDU. This is PBSD plus load balancing. This is the example for it. And then PBSD load balancing again is another method to specify the root bridge to set the spanning tree priority and its switch. This is the configure PBSD plus. And then this is display load balancing, display and verify spanning tree configuration details. So this is the example. The show spanning tree active, and then Apple VLAN 10 spanning tree enabled protocol, and then this is the example for this. So address is blah blah blah. And now the same is the example for load balancing. The spanning tree mode. Rapid PBSD is a Cisco implementation or SDP. We support our SDP in a P per VLAN basis. Next is analyzing the SDP topology. So this is the topology for the SDP. The first one is analyze SDP. Next is discovered layer and topology. Next is prepared expected layer 2 path. And in between of this is we can use the SDP knowledge. Next is verify root bridge, and then the last is confirm layer 2 path through spanning tree VLAN. Expected topology versus actual topology. So this is the difference. The verify active topology matches expected topology. This is example for it. Then overlooking spanning tree status. As we can see, this is the sample S1 it shows spanning tree VLAN. So this is the spanning tree VLAN. This is our root bridge. SDP configure issues spanning tree failures consequences and erroneously moves one or more ports into the forwarding state. Any frame that is flooded by a switch enter to the loop. Repairing spanning tree problem. The problem of the repairing spanning tree, one way to correct spanning tree failure is to manually remove redundant links in the switch network, and either physically or through configuration until all loops are eliminated from the topology. Before restoring the redundant links, determine and correct the cause of the spanning tree failures. Last one is the careful monitor of the network to ensure of the problem to fix. The default gateway limitation. If the default gateway cannot be reached, the local device is unable to send packet off the local network segment. But even if a redundant router exists that could serve as a default gateway for that segment, there is no dynamic method for which these devices can determine the address of a new default gateway. In the router redundancy, multiple routers are configured to work together to present the illusion of the single router to the host of the LAN. The ability of the network to dynamically recover from the failure of devices acting as a default gateway is known as first hop redundancy. So this is our router, the tree router, forwarding router, virtual router, standby router. And this is all our PC. This is the LAN. Of course, this is the internet backbone. This is the example for this. The link or device failure, standby router becomes virtual router. So this is our virtual router. The first hope redundancy protocols, the whole hot standby router protocols or HSRP for IPv6, the virtual router redundancy protocols version, VRRP v3, the gateway load balancing protocols, the first hop redundancy protocols is the standby router protocols or HSRP. HSRP for IPv6, virtual router redundancy protocols version 2, BRRP version 3, gateway load balancing protocols or GLBP, GLBP for IPv6, ICMP, router discovered protocol or IRDP. And then this is the first hop router redundancy option. Group 1 is active and this is the standby. So HSRP defines a group of routers, so one active and one standby. The virtual IP and MAC are shared between the two routers. To verify HSRP state, use the show standby command and then the Cisco proprietary BRRP is a standby protocols. So this is the example for that, the verification. And then the GLP verification, the gateway load balancing protocols, is a Cisco proprietary solution to allow automatic selection and simultaneous use for the multiple available gateway in addition to automatic failover between those gateways. And then the summary for this topic is the IEEE 802.1d is implemented on Cisco switches on a per VLAN basis in the forms of BBSD class. This is the default configuration on Cisco switches. RSTP can be implemented on Cisco switches on per VLAN basis in the form of Rapid BBSD Plus. With BBSD Plus and Rapid BBSD Plus, root bridges can be configured proactively to enabling spanning tree load balancing. The first hope redundancy protocols such as HSRP, VRRP, and GLBP provide alternate default gateway for hosts in the switch environment. Now we are proceeding to our last topic, which is the link aggregation. The basic for it is when the Ethernet channel is configured, the resulting virtual interface is called a port channel. The physical interfaces are bundled together into a port channel interfaces. Either channel can be implemented by grouping multiple physical ports into one or more logical Ether channel links. The advantage for the link aggregation is the most configuration tasks can be done on the Ethernet interfaces instead of on each individual's port, ensuring configured consistency throughout the links. Ether channel relies on existing switch port. There is no need to upgrade the link to faster and more expensive connection to have more bandwidth. The load balancing takes place between the link that are the same Ether channel. Ether channel creates an aggregation that is seen in one logical links. Ether channel provides redundancy because the overall links is seen as one logical connection. Additionally, the loss of one physical link within the channel does not create a change in the topology or no loose connectivity. The limitation in the link aggregation is currently each Ether channel can consist of up to 8 compatibility configured Ethernet ports. The Cisco iOS switch can currently support 6 Ether channels. The traffic cannot be sent into different switches through the same Ether channel links. And then the still requirements is the individual Ether channel group member port configure must be consistent in both devices. If the physical port is one side are configured as trunks, the physical port of the other side must also be configured trunks within the same native VLAN. And now the port aggregation protocol of PAG-P. The Cisco proprietary protocol that aids in the automatic creation of Ether channel lengths. So when the Ether channel length is configured using PAG-P, packets are sent between Ether channel capable ports to negotiate the forming of a channel. When PAG-P identifies matches Ethernet links, it groups the links into either channel. Also, the PAG-P packets are sent every 30 seconds. PAG-P checks out for configuration consistently and manages link additional and failures between two switches. It ensures that when an Ether channel is created, all ports have the same configuration. The last is the Ether channel is then added to the spanning tree as a single port. The modes for the PAG-P or the port aggregation protocols. The first one is on. This mode forces the interface to channel with the PAG-P interfaces configured, and an on mode do not exchange PAG-P packets. The PAG-P desirable. This PAG-P mode places an interface in an active negotiating state in which the interface initiates negotiation with other interfaces by sending PAG-P packets. PAG-P auto, this PAG-P mode places an interface in a passive negotiating state in which the interface responds to the PAG-P packets that it receives, but does not initiate PAG-P negotiate. So this is the sample for PAG-P. S1, S2, the channel stability. If you put it on and on, auto desirable, it's yes, yes. And then auto desirable, not configured, it says no. And you put on, desirable, on, no, and then auto no. The modes of for PAG-P. If all modes are disabled by using the no command, or if no mode is configured, then the Ether channel is disabled. The one mode manually places the interface in the Ether channel without any negotiation. It works only if the other side is also set on. If the other side is set to negotiate parameters through PAG-P, no Ether channel forms because the side that is set to in a on mode does not negotiate. If one side is configured to be in auto mode, it is placed in passive states, waiting for the other side to initiate the Ether channel negotiation. If the other side is also set to auto, the negotiation starts and the Ethernet does not form. The LAC-P or Link Aggregation Control Protocol is a part of IEE specification that allows several physical ports to be bundled to form a single logical. It allows the switch to negotiate an automatic bundle by sending LAC-P packets to the peer. Now defines in a newer IEE 802 standard for local and metropolitan area network can be used to facilitate an Ether channel and multi-vendor environment. The modes for LAC-P, it is on, LAC-P active, LAC-P passive. This mode forces the interface channel without LAC-P. And then this one is the LAC-P. This mode places the port in an active negotiate state. And then the LAC-P mode places the port in a passive negotiated state. So this is the examples of LAC-P. This is the max bundle of LAC-P. It's to define the maximum number of bundle lengths aggregation control, port allow and a port channel. And then this is the LAC-P max bundle, no LAC-P max bundle. the syntax description for the LACP. See the maximum number of bundle ports allowed in the port channel, valid values from 1 to 8, and then the default settings. The 8 bundle ports are per port channel. The maximum of 8 bundle ports and 8 hot standby port, that is port channel. This setting applies if the port channel on both sides of the LACP bundles are configured the same. So the requirements is that either channel support speed and duplex and VLAN matches. The Ethernet supports this interface and our module must support either channel with no requirement that its interfaces be physically contiguous and in the same module. The range of VLAN is configurational, and either channel supports the same allow range VLAN and the interfaces and the tracking either channel. And now the procedure. Step 1 specify the interfaces that compose the ether channel group using global configuration mode command. So this is the example for it. And a good practice is to start by shutting down those interfaces so that any incomplete configuration did not create a link. Step 2 is to create the port channel interface with a command and interface range configuration. Identify mode active. Step 3, select the channel and configure the channel. And select it. For verification, it shows interface port channel commands display the general status. Show inter-channel summary commands simply display one line information port channel. Show inter-channel port channel commands to display information about the specific channel interface and provide information about the interface in the either channel. The troubleshooting. Assign all ports in the Ethernet channel for the same VLAN. Configure them as a trunk when configuring an Ether channel. And Ether channel support the same allowing range VLAN on all ports. The dynamic negotiation option for PIP and LACP must be compatible, configured in both ends of the Ether channel. Now this is the show Ether channel summary for it, and then this one, and then the last is note of the Ether channel spanning tree must interoperate. For this reason, the order in which Ether channel related commands are entered in is important. This is why using this interface port channel when removed and then re-added with the channel group command as opposed to directly change. If one tries to change the configuration directly, spanning tree errors cause the associated port to go into the blocking or in disable state. So this is all, and then done for the discussing on it, and then later I will show you the laboratory exercise for this topic. Thank you.